Hello, welcome back to this channel. In the last video we have discussed concepts related to cone, where you have understood curved surface area of cone, total surface area of cone, volume of cone, and formula for calculating slant height of the cone. In this video we will discuss concepts related to sphere and hemisphere. So let's understand. So it's talking about concepts related to sphere. So I'll show one example of sphere, this rubber ball as an example of sphere. So let's understand what I want to say about sphere. This is sphere, right? So for this sphere, if through this ball, if I take this edge, you can see this boundary here, right? This can be taken as the base, right? In case of sphere, its height will be radius. Its height will be radius. I repeat, this edge you can see in this ball can be taken as is its base. So same formula remains. Like in case of sphere, there is no CSA TSA, we call it as surface area only. So when we say surface area of sphere, right, same thing I will repeat as I discussed in the first video. General formula: area of anything is base into its height, right? So when we say that this is the base, this portion, that means that is circumference of circle, which is its 2 pi r. And when we say this dotted line is its height, so its height is r, right? R above this and r below this. So its total height is what? Its total height equals to its diameter. That means this r plus r, right? So its total height will be nothing but 2r. So coming back to the same formula, surface area of sphere is what? Base. Base is what? 2 pi r. What is its height? 2r. What is total? 2 2s are 4. So this is 4 pi r square. I hope it is clear. Surface area of a sphere. I repeat, in case of sphere there is no CSA TSA. We call it as surface area when it is a full sphere, right? Coming back to its volume, and then I'll take the formulas for hemisphere. So when it comes to volume, I'll make another diagram to make you understand. So here I'm talking about this was surface area, right? And here I'm talking about volume. So when I say volume, so in this sphere, right, if suppose, try to understand, through this ball, right, if I just cut out this piece, one piece where T is written, right, this shaded, let me shade it for you. So this shaded part, when I remove it, right, try to understand, when I remove this part, when I take it out, it will look like somewhat like this. Try to understand. This is just one part, one piece of this, and this one piece is nothing but definitely it is a 3D piece. I hope this is clear. So as it is 3D piece, so this portion, this I'm talking about this part, right? This is nothing but this from here to here, from here to here, from here to here, and from here to here is radius. It's like one piece of lemon, right? So this portion, let's say I'm taking it as A1, which is area 1, right? So when I talk about the total area of this face, like this we have n areas, right? So if I talk about the volume of this one piece, volume of one, this piece I'm talking about, this piece is nothing but, we can say it's a prism, or you can say one object which is look like a conical, right? So in this case the volume of one piece is nothing but, as it is conical kind of, so this is 1/3, right, into its base area. Base area is nothing but this portion, I'm writing it as A1, and its height is nothing but R. I hope this is clear. This is volume of one piece. Similarly, when you see this ball, right, everywhere we have this part, right, so many pieces are there, right? So from this part, try to understand. So total volume of the sphere, total volume of the sphere equals to 1/3 into A1 into R plus 1/3 into A2 into R plus up to plus 1/3 AN into R. I hope this is clear to you all. I repeat, this is only volume of one piece, right? Like this we have, let's say, n pieces in this case, right? You can compare this explanation with the custard apple, right? So in Hindi we call it as sitafal. When you remove one piece, it's one piece that looks like this, right? So in this case we can take it as 1/3 R, in bracket you have A1 plus A2 plus up to AN, and friends, this is 1/3 R into, when you will join this all areas, when you will join small areas, right, of this face, that will give us total surface area of this sphere, that will give us total surface area of this ball, and total surface area of this ball is what? 4 pi r square. 4 pi r square, and when you will multiply these two, it will become 4 by 3 pi r cube, which is nothing but volume of a sphere. I hope it is clear to you all and you have understood this, right? Going ahead with formulas for hemisphere, it's very simple, right? When I talk about hemisphere, right, so in case of hemisphere you can compare it with the half lemon. In case of hemisphere the things remain same. In this case we have CSA and TSA. So first I'll talk about curved surface area. So curved surface area will be again base into its height. So friends, the base is this part, which is nothing but 2 pi r, and from this portion its height will be nothing but radius, so that will become 2 pi r into r. Answer is 2 pi r square. I hope this is clear. And when it comes to TSA, so TSA is nothing but CSA 2 pi r square plus area of its base. And what is the area of its base, friends? That is pi r square. So TSA of hemisphere will be 3 pi r square. I hope this is clear to you all. And when it comes to volume, so volume will be exactly half of the volume of the complete sphere, which is 4 by 3 pi r cube. So in this case volume of hemisphere will be half into 4 by 3 pi r cube. So this 2 cancel, 2 2s are, right? So we are getting 2 by 3 pi r cube. I hope it is clear to you all, right? I repeat, so the volume will be exactly half of this volume, which means half of 4 by 3 pi r cube, which can be expressed as 2 by 3 pi r cube. I hope this is clear. Hope you have understood surface area of sphere volume of sphere, CSA of hemisphere, TSA of hemisphere, and volume of hemisphere. Thank you so much for watching this video. Hope you have understood these concepts. Hope you will like and share it with your friends. Thank you so much, everyone.